Hi everyone, good morning, good afternoon, good evening, wherever you are. Let me just go ahead and share what we're going to speak about today. So, today we're going to be speaking about deep observability, technology automating threat modeling. And we have Amitabh with us. Amitabh co founded Avocado Systems. This is a leader in application security and compliance. Its technology creates dynamic software microsegments to ensure isolation and protection of the application and APIs. Thank you so much, Amitabh, for joining me today. Over to you.
Thank you, Vandana, for a very generous introduction. Let me start actually sharing if we can see if I'm. Are you able to see my presentation? Yes? No?
Yes,
Okay. Okay.
absolutely.
Okay, great. So I will just play it in the presentation mode. So today we are going to cover deep observability, as Vandana mentioned, technology, how it enables the threat modeling, rather automates the threat modeling component, which is obviously it's very time consuming and it's kind of it takes a while to complete the threat modeling. So just about myself, I am the chief product officer at Avocado Systems. We co-founded this company about, I would say, 4 or 5 years ago, and we are based out of Silicon Valley, Milpitas to be precise. And of course, we have a big presence in Pune, India, as well. So we have developers as well as QA folks over there. Uh, Prior to Avocado Systems, I was at Symantec. I was working there. I was leading some of those product lines in data protection area. I was based out of Mountain View campus. And prior to Symantec, I worked at various other companies such as Commvault System, Network Appliance, and various other startups in the Valley, which were acquired by companies like EMC and so on. So with that, let me go ahead and start. The agenda is very simple, as Vandana mentioned. We are going to just go through some of those AppSec challenges. What are some of the key challenges? How people are mitigating those challenges, and what are some of those current approaches by which customers or developers are able to, mitigate those challenges that we have on the application development side. More importantly, of course, you all are very familiar with some of those tool chains like SAS, DAST, and other tools, which are kind of very dominant in the industry for AppSec, but they are kind of like application security testing tools. But there are some, as you can see, there are like new next generation of advanced persistent threats or zero-day attacks. How do you detect them in dev test environment? That's the key discussion that we are going to have. And I will share some of those JSON files that we are able to provide, and how they can help creating the threat modeling. Okay. With that, let's look at what's happening with the application and the product security these days, right? So, of course, application development has transformed, right? Previously, we used to have waterfall to agile. So, I still remember going through like creating a PRD for like product requirement document for like 3 months, and then working like let engineering work on those product requirement documents and things like that. These days things have all changed, right? So now we are like we are working in very fast agile, lean agile methodology, which is very quick, and it's like 2 week worth of sprint. And I'm pretty sure all of the development and test processes, they follow these kind of lean agile methodologies, right? Monolithic to microservices, right? So initially, as you can see, the applications were like big honky file servers and big servers and appliances, and one single application running on those big servers. Now this is an era where on that particular big server you have like hundreds of containers running or microservices running, and they are talking to each other. How do you secure in these kind of environments, right? And of course, open source. I'm pretty sure as a OWASP community and DevSec community, you are all using. You're a big fan of open source um, code base as well, right? And of course, everybody is familiar that there are so many tools, right? There's a tool sprawl, if you will, if you in the development and testing process, wherein there are so many tools. The challenge is they are all detecting the stuff, but how to troubleshoot, how to nail down where the underlying issues are, right? That's the key thing. That's a very time consuming still, even though there are like so many tools out there. So there's lack of automation as well. There are lots of false positives or false negatives, right? And it's very challenging to identify what's going on really. And ultimately, the goal is to identify these vulnerabilities and troubleshoot these vulnerabilities, because we don't want developers to waste time in in days and so on, because when you are in like agile process, or you have agile delivery methodology, then you need to deliver things very, very fast, right? So, and of course, lack of collaboration is another area. So let's look at how the application security has evolved over the period of time, right? So as you can see, AppSec 1.0, it was basically focusing on the code scanning, right? So as developers are writing the code, right, it will scan, and that is still very true as a matter of fact. So all these SaaS DAS tools, they're kind of very dominant at that time, right? And the key benefits of that those tool chains, or like it catches the code specific vulnerabilities during development stage. It's not when the application starts running, right? So that's the key difference over there. So as it mentions, the challenges were in this AppSec 1.0. It's like it does not address the vulnerabilities in dynamic applications, right? Distributed application. Imagine hundreds of microservices which are running all together. They're communicating with each other. How they are communicating? Are there any rogue processes which are communicating with these key applications or critical applications? What kind of payload they are exchanging, what kind of SQL statements they are exchanging, right? Those visibility is not there, right? Was not there. So then we graduated into AppSec 2.0. It's like north south. So at any given time, when I say in a data center, there are two types of traffics, right? So north south, somebody is coming inside the data center. East west is basically within the data center. So east, so somebody coming in via the perimetry security devices or perimetry is kind of, I consider that as north south. And the east west is like literally moving within server to, yeah, like an application may have app tier, DB tier, and web tier, and so on, right? So AppSec 2.0 is basically mainly focused on north-south perimetry kind of security. Think of like web application firewalls, runtime securities as well, application security. And the key benefits there were like it basically, most of these devices, they worked on a signature based or behavior based analysis tools or threat detection methods, right? And as a result, they were only able to detect the known vulnerabilities at runtime, right? But some of those challenges were like they must be compiled. The code, the technology, or the threat detection mechanism or the tool set must be configured and compiled. And it was very, very language specific. So, for example, you have the tool set for Java application, you have tool set for certain other programming languages, and so on, right? So it was kind of very difficult to maintain. And then now, what I consider is the era of AppSec 3.0, which is providing the observability, automated threat modeling, is cutting down. Then I'll go through the details, like what exactly what I mean by that. It's basically, as you can see, most of those threats that you are seeing out there, they are actually somebody coming inside the data center or in the cloud instance or your VPC, if you will, and they are spreading laterally, right? Because as you have seen over the period of time, lots of attacks, very recent attacks, very sophisticated attacks. In fact, a couple of days ago, there was a news I was reading, like Microsoft's code base on certain technologies or products was kind of compromised. Right, there was a big attack, and particularly the Russian and Ukraine war happening. So as a result, there are like lots of threats. Everybody is kind of scared. Say, lots of threats will be coming in on, and they could be state sponsored, right? So all these next generation AppSec 3.0, it basically it provides not only a mitigation to the known vulnerabilities, but also the unknown vulnerabilities. What's that key difference over here? Known is, of course, you have the signature, you have the behavior-based analysis done, or at least known for that particular threat. But unknown vulnerability is like that threat is zero-day attack, which was just created today, or there is no signature out there in the market, or nobody knows how it behaves, right? So these are some of those benefits of observability technology, wherein we are able to detect those vulnerabilities which are not only known but also unknown, right? Uh, just wanted to give you some kind of this is a market slide. Basically, just wanted to, it's a huge market for DevSecOps, and I'm pretty sure you all are very familiar with this. Just wanted to highlight few key points. I don't need to go through all of these, right? So it's a huge market, $17 billion, with compound aggregate growth rate of 24%, which is kind of very handsome growth in my opinion, right? So as you can see, vulnerability scanners only offer a static view at a single moment in time and may not detect the potential runtime threats. And this is a very key point, right? All these SAST and DAS tools, they are kind of giving you point in time what's going on. Somebody writes that statement or the string within the code, and that code is analyzed backend using some of those engines over there, AI ML engines, and it comes back with, hey, this has a potential of a breach or threat, right? Those are kind of very static. They are looking at the code and so on. And one key thing I want to mention over here is, as I mentioned earlier, there are lots of open source code, and there are shared libraries out there which are kind of there is no availability of the code to crawl. So all these tools which are not able to scan the code, such as open source library and so on, they declare that as a false positive. So as there are plethora of open source which is being adopted by various developers, it is becoming challenging, because if there are lots of false positives, and if they are not able to investigate, then it's a challenge, right? And of course, as you know, there is a big shortage of resources within the security, application security, particularly in the industry, because I think if I remember correctly, there are like millions of job openings for security professionals. So as a result, we need to provide lots of automation, less amount of false positive, because we don't have in the SOC or in dev environment people to look at if or analyze the false positives. Hey, is it real false positive, or is something really wrong, or it's just a false positive, right? Now, as you can see, APIs are taking the center stage these days, right? So API based applications are deployed, and they are kind of very instrumental between the applications. So APIs are communicating with various microservices and they are bringing in lots of data across. How do we make sure that those APIs are also have gone through some of those application security testing concepts or those tools, right? So this is kind of very important, right? And finally, zero trust perimeter security models alone are not sufficient, right? I mean, of course, you have the network based zero trust, or micro segmentation, some of those new technologies. But at the same time, there are some technologies which are kind of addressing the zero trust or micro segmentation within the application, right? I think we need to adopt some of those technologies so that we can address or maintain the zero trust among the applications as well. And over here, as you can see, right, 87% of the organizations shifting to zero trust architecture post COVID 19, right? So it's lots of folks are working from home. It's kind of perimetry is kind of in the process of dissolving, right? And lots of 80% traffic is east west, right? So somebody's so one of those Google query that you perform that goes to the web server, and then web server takes that query and spreads it to queries the backend applications servers, as well as fetches the data from the databases and so on, right? In fact, the key issue here is the 40% of these app to app transaction, which is like uh, it could be microservices based applications or container based applications and so on. They are kind of increasing app to app transaction, and they are mostly using the APIs and so on, right? How do we secure APIs and so on? So let me walk through some of those challenges and solutions of the traditional AppSecs. It's a details, very detailed slide, but I will go very quickly on this. So traditionally, you have the security features in AppSec, right? So as I mentioned, there are like SAS tools, static code analysis kind of tools, dynamic application security testing, SCA, like which is stands for software composition analysis. As I mentioned, they are point in time, right? They are not persistent. They are taking the snapshot at one of those static moments, right? In NetSec or network security, they are persistent, but again, they have no insight into the application, right? Because they are just like on the perimetry level, and they are not engaged with the application. They have no visibility into the application, right? They are kind of ubiquitous, right? What that means is application security testing does not cover every application API or microservice. They are very specific to certain like codes and and vulnerabilities, and like in NetSec, it doesn't cover every app or especially every API that is the part of the application ecosystem. When I say application over here, what I mean by application is, in my opinion, application is a collection of various sub applications or sub modules. And for example, you may have a big application where there are like 50 sub applications or sub modules, some running on the web tier, some running on the backend application tier, and then of course the database applications as well, right? Instantaneous, right? What that means is like all the application security testing tools, they detect the vulnerabilities uh, post factum, right? What that means is they're basing their threat detection on the signature based or behavior based analysis, and of course there's a new term I want to coin over here, which is RASP, runtime application self protection. That is instantaneous, but it's not very common, right? And in NetSec, of course, it's instantaneous, but it's once again, it's no all the network security appliances or control functions. They don't have any access to the application or insight to the applications, right? They are actually micro level, right? So for example, application security tools, they are macro level, right? They cannot their attack surface is like kind of very large, right? They cannot detect, inspect APIs at the process level. There is no zero trust kind of functionality they can provide. And in NetSec, I think that is also true. because they are mainly targeting at the perimetry security level. Autonomous. This is a key attribute of any AppSec or NetSec, right? So there are lots of, when you are dealing with these AppSec tools, uh, autonomous or automation is a key thing, right? Because there are lots of policies needs to be configured, or tuning needs to happen, and so on. Very similar to NetSec, right? When the workloads move from one server, one host ESX server to another ESX server, then you have to change the policies and things like that, and it's a overwhelming amount of human intervention required over there. Across the ecosystem, that's another one, right? So application security testing, runtime application self protection, they cover just an app, right? They are not looking at application communication specific vulnerabilities or application communication types of security events or signals, right? Because as I mentioned, with the distributed application architecture, these applications are talking to each other, and they are exchanging, the APIs are exchanging lots of data. How do we make sure that the data that is being exchanged using APIs is in pristine condition, it's not compromised, or its integrity is not broken, right? And self-diagnostic monitoring and protection, as I mentioned, there are like less number of people, always everybody's doing the fire drill kind of thing. So self diagnostic and monitoring is one of those key attributes of the application security, which is kind of missing right now. It's only actually right now it's like kind of missing. Only externally it is available, which is basically monitoring and protecting the applications. And this is the key one. This is the topic that we are discussing today: observability of unknown. Right? Of course, most of the known threats or vulnerabilities are out there, like they are using the signatures and patterns matching and behavior matching, but they are only restricted to certain types of attacks and threats, right? So they cannot detect zero day attack or ATAs or advanced persistent threats and so on. And the same thing happens in the network security tools. They also provide the similar kind of threat detection technology. Now, what happens over here, right? What should be the ideal thing, or ideal holy grail of these security features or attributes, right? So, of course, the application security should be persistent, right? Means once it is installed within a server, within an application, all processes or sub processes or scripts or executables that are related to that particular application ecosystem, they are automatically protected. We don't have to whitelist all these applications and processes and everything in order to protect. So as soon as a new process spawns, it automatically should get the security controls, and it should be able to detect the threats throughout the application lifecycle, right? uh, so every app and every server, every workload should be instrumented and secured, right? It should be instantaneous, right? So it's not like, okay, I have detected a threat, and then somebody needs to uh, look at whether it's a false positive or it's a really threat or something like that. And it protects at the moment of crime, right? So if somebody is trying to attack, and that's the moment of the crime or attack, what is happening, and it should be detected right at that moment, and it should be thwarted at that moment itself, right? Micro level, not macro level. So at the API level, the process based segmentation or micro segmentation, that is very, very critical, so that, of course, there are threats which will get in, right? So we need to have some kind of uh, technology that enables the, hey, nobody should be able to get inside these application segments, or once the communication channel is found between applications like web applications and backend application and databases and so on, right? This is the key thing, right? As I mentioned, there are not many people over there to just keep on playing or working on the configurations and fine tuning, right? It should be autonomous. Once it is set, doesn't matter how many sub applications or processes are coming up online or working in conjunction with the parent application, they are all uh, adopting the same DNA of the security functions, and they are able to protect themselves, right, across the ecosystem, right? What that means is within the application, inter or intra applications, APIs, which are bringing the data from the various applications and databases, it should be across the entire application ecosystem, right? And it should be diagnosable, right? And should be monitoring and protection enabled, right? And this is the key point, which is observability of unknown, right? Detects the unknown attacks, zero-day attacks. As you know, the attacks are becoming very, very sophisticated, and some of the attacks like solar winds, right? I mean, the bad guys, they came in, they infected the supply chain servers, and as a result, uh, like entire customers set of SolarWind, like 16,000 of them, they had this malicious vulnerability which allowed the remote code execution. And then, of course, you saw this Log4j, which is remote code execution as well, right? So these were just very sophisticated attack, unknown attacks. There were no signatures, nothing whatsoever. So, of course, I don't want to read the entire slide, but the key point I was trying to make over here is there's a key difference between, there's sometimes a confusion like what is monitoring, what is observability. The key thing is, in monitoring, tells you that something is not right. Of course, it's monitoring, continuously monitoring the communication, as well as what's happening, what alerts are being generated. But the observability tells you where that problem lies, where so somebody is uh, doing the SQL injection, right? Now, if you need to understand where the SQL injection is coming from, what kind of statements are SQL statements are being exchanged, and how to and what how why this matters, because it simplifies it, it cuts down the troubleshooting time significantly, right? So, of course, continuous monitoring is important, but continuous observability, deep observability at the process level is also very, very important and critical. I'm pretty sure you guys are all very familiar with this DevSec Ops lifecycle diagram, right? So, most of you guys are focused on the left side of this diagram, which is kind of people refer as shift left, and this is where the application development happens, application testing happens, and lots of tool sets or tool chains are available in this shift left area, right? So as the program or the application is being created, it is being planned. So developers are getting together, hey, I want to create this e-commerce application. It will have like web application, web processes, and then it will go to the mid tier, middle tier, or middleware, and then it will have backend databases which will go through some of these data crunching, and data and APIs will bring in that data and give the results to the web application, whatever the e-commerce application is trying to do. Right? So during that process, at that time when the planning is happening, right, there is no application as such in that at that point in time, right? It's only on a piece of paper or whiteboards and things like that, right? So it's very difficult to understand how these applications they are going to. Of course, they have some idea like these application A will talk to application B and C and so on, but what are the other components, what are the processes which are within the application, how they will communicate, what are the APIs, what kind of information or data they will exchange, right? That visibility is not there. It's only on paper at that time, right? And then code is being developed, and of course it's verified, like application security testing tools, the kind of DAST kind of tools comes into the picture, which is at that time it performs, like application starts running, application is has some kind of backend applications, databases, web tier, and they come together and they form one single application. They run as an application, right? So DAS technologies, they are not able to detect what is being exchanged within, like their like what is being exchanged within the application, how these APIs are communicating with each other, right? Which applications, or like which applications are being attacked. For example, if there is somebody knowingly or unknowingly has embedded some of those vulnerabilities or some additional hooks which are coming alive at a certain time after 1 week or 2 weeks within the product or the application, and they are talking to somebody outside, some vulnerable sites, and fishing out all that information. Because if you look at it, right, lots of threats or attacks, they kind of stay dormant for some time, and they suddenly wake up at the given time, or whatever the triggering event is, and they start looking at like lateral movement, looking at which is the vulnerable server, and they start compromising that information, send that information to other sources. So we are able to provide that kind of visibility using the observability tool, wherein if a client or unknown client or unknown server is trying to reach out or connect to the application, we'll immediately capture that level of information and provide the deep visibility into it. And of course, once the application is fully tested and we have isolated, we have identified all the vulnerabilities, runtime communication related vulnerabilities, we are able to, of course, we can never say, hey, this is like 100% secure, right? The applications are still kind of vulnerable, right? Because God knows how many different types of vulnerabilities are out there. So what happens over here is when the application is pushed in production, which is the shifting right, uh, it's also important that we make sure that these applications are running in pristine environment, pristine conditions, and they are none of these zero-day attacks or known or unknown attacks are able to attack them. So how does this observability technology works, right? So here's a like kind of very, very simple diagram I wanted to explain. So so what they do is, as you know, that like in a typical environment, in server environment, you have of course you have network connectivity, and then you have operating system, kernel, OS, operating system, and then you have the application processes and applications running, right? And all these applications, they have like they communicate with each other using the sockets, right? So using of course there are technologies like kind of which are providing these kind of visualization or observability using the application agents which are installed on the OS or kernel level. But those are sometimes very language dependent, as I talked about earlier. So for example, for Java, you need specific agents and so on. And they are kind of very heavy duty agents, right? They're full-time active 24/7. So the new concept, which is very popular these days, is like plugin based approach, which is the plugin is something that sits in the user space, that is communicating with the application at the socket layer. Their plugins are sitting, and plugins are nothing but a set of two libraries or the libraries which are kind of interacting or in place when the application communicates with the operating system and so on, right? And so like your glibc and so on. So the plugin is a key component which is sitting with the application, and as new processes are coming in related to that particular application, all of these processes and sub applications, they get the DNA of this particular plugin. And once, because plugin is sitting at the socket level and it has full visibility of what is being exchanged, who is talking to whom, right? So it is able to provide the entire application telemetry, right? How many application servers are there? How many web application? How many Tomcat or Oracles of the world, and so on, right? All that information is very, very detailed, and how many processes, how many APIs, what are the key communications happening, whether is whether the application is trying to communicate with somebody outside the world or not. All those kind of information telemetry is provided, right? Of course, known good tracking is also provided, because the plugin is also creating a, if you can think of like a segmentation. It's a like a, it's a, think of micro segmentation is very dedicated pipe to the applications communication and the processes. It is making sure that no rogue process or no rogue application communication is able to get intercept these communication when these two applications are talking to each other. Now, of course, the zero trust enforcement, of course, zero trust is a kind of buzzword these days, but and of course, zero trust happens at various levels, right? Network level and so on. However, in this case, the plugin is able to provide the zero trust at the application. It's a software defined zero trust, software defined micro segmentation. And there is no need to configure any policies. And this is the magic, basically, right? Micro segmentation requires lots of policies, and because the technology is based out of the network concept, right? So in this case, the plugins are software defined. They are providing the software defined micro segmentation, if you will. And of course, the compliance controls are also very critical, because plugins, they have the capability to understand, they because they are sitting at the socket descriptor level, they're able to look at what is being exchanged, right? What data they are looking at, the payload, or what SQL statements. And imagine a situation where the development environment is kind of looking for, hey, I don't, this is a PCI environment, or HIPAA or some compliance environment. I don't want the compliance data to go out of my application or my database or to anywhere, right? So so the plugins are continuously looking at that kind of level of details, and they are able to provide, as soon as they see something that is string matches the regex expression, then they are able to stop that communication altogether, and they are able to securely maintain that data. And of course, data policies, like there are like so many known data policy kind of controls over there for SQL, which I'm pretty sure, being a OWASP champions, you guys already know. So imagine the plugins, the power of the plugin, which is providing per application, per process, visibility, observability, and controls, not only to the application, but also the data, right? So think about this, right? So application, where the application belongs, right? Domains, subdomains, zones, and so on, right? What kind of APIs are being called, RESTful APIs, what URLs, standard proprietary APIs, open source APIs, and so on, right? What kind of data it is accessing, right? What kind of tables, what kind of records it is fetching in order to furnish the customer's request, or application's request, right? It is not only targeting the north-south services, but also more so on the east-west. And once again, east-west is like lateral application communication, and this could be like web application talking to backend application, and then backend application talking a database application here. Similar thing within the data construct, right? A key thing is like you can do the data type target various data types, right? You can identify what kind of data it is, and you can target the various data types, like whether PCI data, HIPAA data, or some specific compliance like GDPR data or PII data. All those kind of user contexts you can add, and make sure that applications are kind of protected, as well as the data is protected. So think about like scaling that to hundreds of applications, thousands of processes, and so on, right? So this is how you can scale the applications and application development, and you have full visibility into uh, once you get that plugin installed, you have plugins start learning, or not learning, but collecting the data about the process communications, and they come out with a structured JSON object, right? So this is a JSON file. I will show you later. And what it does, it provides you all this information, as you can see, 6 points over there, which I call like systems of insight. So application execution platform, right? Plug and play. They are kind of plug and play, built-in applications, data native controls, autonomous for scale of deployment, and they are kind of very much they are secure. But it doesn't matter whether the workloads are in the public cloud, private cloud, or hybrid cloud, or in multi-cloud, right? So uh, the segmentation, micro segmentation, and the plugins are able to deploy across the board. So as I mentioned, the application could be, at various locations, and we can make sure that, hey, these could be a web tier, this could be application tier, this could be a database tier, and they are kind of forming a micro segmentation, if you will, to ensure that this communication is in pristine order, pristine condition. Nobody else, no rogue process, no rogue actor or vector can intercept into these processes and perform attacks like middle man in the middle, or zero day attacks or anything like that, and stop the data exfiltration. So once we have all these plugins deployed across the test application and developed application and test applications, we are able to provide that JSON file, as I mentioned, and that JSON file can be read into any of these OWASP tools, like for example, ThreadDragon. And what you are seeing over here is a ThreadDragon map, which is kind of and this is the map uh, which is kind of takes very very long time. It's a lots of manual efforts. Right now it is kind of only done in like with after discussing with various folks, engineering team members, and so on. And as I mentioned earlier, it takes maybe weeks and months and so on. And of course this is based on the abstract information, right? And what are the challenges with that information? There are like, it's not, most of the time it's not correct or accurate, right? Because it's just like lots of abstract information, lots of gases and things like that. Now what these plugins or observability plugins are able to provide here is they have automated that threat modeling process. So uh, as the plugins are deployed across the application, they understand how many applications are there, how many APIs are out there, how many processes are being spawned, how they are talking to each other, and all that information is captured in the JSON file. And then JSON file provides, you can read it like with the ThreadDragon, if you will, or there are like various other tools as well, threat modeling tool, which are able to provide these details, how these applications are. And I will show you a detailed diagram over there, how these applications are talking to each other, and what are some of those vulnerabilities. Like in here you can see like there are SQL injection attacks being performed by, and to be honest with you, it can even provide you what statements are being executed, what strings are being executed over there, right? And the key benefit of all that information is your ability to quickly troubleshoot. Hey, oh, this is what's happening, this is the root cause, and you finally go and fix it rather than like spending hours or days to fix the vulnerabilities. So this JSON file is like fully automated. What does it do? Right, fully automated. It provides a multi-tier, web tier, app tier, DB tier application discoverability, deep level of application payload visibility. So what is being exchanged within the payload? What kind of SQL statement? What's all the details of the session information is provided there, right? Which are the how many clients are connecting, how many unknown clients, right? Some clients which I don't know about, right? Where they are coming from, all the IP addresses, port numbers, all that information, what the process ITs are, what APIs, URL, all deep level of database payload visibility is provided in that JSON output, which can be fed into these like threat modeling tool and so on, right? So in summary, you have, of course, workload and you have the data, right? So these are the two aspects of attributes of the applications, right? Of course, each of these workloads, you have some location specific attributes, right? APIs, what kind of APIs they are using, what are the dependent processes or applications they are running, and what kind of data they are accessing. Are they accessing any compliance data, or are they not supposed to access the compliance data? And if they are doing it, then who are these rogue processes or rogue actors which are accessing this, right? All that information, and then you can make also the informed decisions. So let's say if you see some rogue data, rogue process, or rogue actor is exchanging the data, then you can actually block that that attempt. At the same time, you can encrypt the data on demand as well using the plugins. So with that, I will just what I will do is I'll show you some uh, some key attacks that I don't have the setup for like showing the live attacks, but I will just walk through how they happen and some of the JSONs that we have captured, right? So this is the log4j Apache logging attack, right? The CV vulnerability like 44228, right? So as you could see over here, there were like Linux virtual machines, and of course the backend. This is web tier, app tier, and DB tier, right? This bad guy or rogue actor kind of perform, but of course they were kind of leveraging this log4j vulnerability, remote code execution vulnerability, right? So hacker sends in a command, root remote command execution, right? JIND, if you will, Java native directory integration kind of command to this particular web tier or web application. And as soon as this uh, web application, I mean, of course, it has the vulnerability. It kind of goes to the application tier, and then application tier actually connects the remote code execution connects with this uh, LDAP server, and LDAP server basically goes in and copies the Java based application over there, and then once the Java based application is copied over there, it is executed and it's basically making a connection over here, giving the full control to the hacker, and as a result, the hacker now can move laterally within the other databases or other servers and so on, and it can fish out all the database, if you will. This is exactly what happened. And very, very serious um, attacking event that took place, right? Now imagine if you have these observability plugins, like what will happen, right? Of course, when these plugins are working in these fashions, right, they're kind of forming the segmentation, micro segmentation, if you will, right? So imagine what happens. Same scenario, right? Of course, we have some of those regex-based expressions over there, tool chain, that will which are residing on the web tier. As soon as this hacker sends the jindy command and it says, "Hey, this matches the pattern of 4422A," immediately this is dropped. But then again, you might be thinking, "Hey, this is like this is the known vulnerability, right? This the web tier can only stop this vulnerability if there is there is a known attack of that nature." And but what happens here is, imagine this, because these plugins, they are not they are also protecting from unknown attacks. So we will just say, hey, there is no regex expression or no policy, data policy, that is detecting the 44228 vulnerability. So let the attack go through and see what happens, right? So once the plugin is over here, the attacker moves here and tries to communicate with this LDAP server, right? And as soon as it tries to communicate with the LDAP server, the plugins stop that attempt, right? In case, let's say, if it goes through as well and is able to download the Java application over here, right? Then the Java application comes up and it starts this is a remote code. It starts trying to execute the vulnerability over there. And then immediately, as soon as that happens, we stop that execution. Why? Because we do not identify that application as a registered applications, or we identify, hey, this is a rogue process using our AI ML engine, right? And as a result, that communication to the hacker is also stopped, right? We stop any, because we are not allowing any communication whatsoever to the outside world. The only communication which needs to happen is between these micro segment that we have formed, and that's the only allowed communication, right? And as a result, there is no communication to the hacker out there, and as a result, there is no database or data phishing out to the application hacker, right? So that's the kind of attack I just wanted to show. Let me switch gears and show you some of those threat models I want to show, right? So this is what I wanted to show you. So uh, based upon the JSON file that we have created using the plugins, right? It provides all that good information about how many applications are out there. As you know, there are like unknown clients. This is Java applications, MySQL server, and that's how they are communicating with each other. What protocol they are using, UDP, TCP, and so on, right? And all that information is provided, like what what port, what IP addresses, and so on. And if you look at this like managed threads of these items, right? You say, hey, these are some of those applications or the clients which have a potential of cross-site scripting, right? These applications, they have the potential of SQL injections, right? Or they are being attacked by the SQL injection attackers, right? All that information is provided, and as you can see over here, you can get all the information about the payload, what is being submitted to the SQL query, what SQL statements are being executed, and so on. And what this allows you to do is simply have better visibility, better observability of the application attacks. At the same time, it cuts down the troubleshooting time, right? So, hey, I now know that what statements are being executed, what statements are being or which clients are coming in. So I might fine tune my firewall and or application web application firewall, and block those IP addresses where it is trying to communicate with those outside world. So these are some of those kind of information I wanted to provide. At the same time, there are other, this is a kind of JSON output file. As you can see, it has all the details of the applications, session details, uh, what kind of uh, you know uh, application it is, right, where it is coming from, what type of process it is executing. And this is like a application name, all the what kind of rules are embedded, right? These are the data policies that we have. And as you can see, these are like SQL injections rules. These are for the to identify like certain vulnerabilities, specific known vulnerabilities, right? However, at the same time, you are able to detect the sessions, like full session information, and you are able to let me open another session, like another file. Uh, so as you can see over here, various SQL statements are being actually this is the same file. So as you can see over here, there are various different types of information provided, all the session information, right? And it's application IP addresses, as well as various session information. All that information is provided to the application developers during the runtime, and what rather than basing the facts on the paper based or like Visio based or PowerPoint based threat modeling. This is the most accurate way of doing the threat modeling within hours rather than weeks and months, as well as it is more precise and is more accurate. So with that information, I wanted to end my presentation. It has been, I know it's a long presentation and long discussion. It has been a pleasure talking to you folks. At this time, if there are any questions, I would like to uh, answer those questions. Hello, Vanda. Yeah, I see a question over here. How long does it take to model a process uh, for each app? As I mentioned in the beginning, right? Usually, this kind of process it takes hours and not hours, but weeks and months, right? In our case, these plugins, observability plugins, they kind of sit next to the applications, and the key thing is not only the timing, but it's all automated and accurate information, right? So it takes only maybe a couple of hours, depending upon how big or how large the application is. Any other questions?
I've been checking for the questions. I don't think so. There is any other question, but
Okay,
that was a very informative session.
thank
Especially,
you.
I would love to get your slides around observability and the way you explained it with the whole DevSecOps process. Because right now, chaos engineering and observability is something which is needed, and
Yes.
people are still not aware more about observability things.
Yeah, no, absolutely right. And I would love to
Yeah.
spend more time with you and other OWASP or DevSecOps community. Definitely,
Any day.
anytime, because this is we are kind of provide. I think we strongly believe that we are providing a great solution, particularly in the these critical times, right? Where these wars are happening, cyber attacks are coming in every now and day, every moment, if you will, right? So definitely, we would like to be a good citizen and with good interest and to protect the national assets and so on. Thank you, Vandana.
Right.
Thank you
Thank
for giving me the opportunity to present, and of course, we look forward to and I would like to I've given the information on my presentations. If somebody wants to reach out to me directly to learn more, and just have a like live demo, I would be more than happy to do that. My email again is asinha@avocado.sys, and please connect with me directly. Thank you so much.
Sure. Thank you so much, Amitabh, for joining us today. And everyone, this session would be there as recorded, so you can tune in again. Thank you. Thanks, everyone.
Thank you. Bye now.